Okay, now you guys should have sound. Again, I did that. So, no, I was just saying, what's new? Nothing's new, but December has been my busiest month so far in business. So, that's good, I guess. So today we're gonna be working on a 820000165. This is the same board from the other night. Does something a little bit strange. It'll turn on, but it'll shut off right away. But it will work if you press down on the I/O connector. I was originally thinking, okay, maybe I could just get away with touching it up, but no, we need to replace the I/O connector on this board. So we get no green light in the charger, but if we push down just right, it'll work properly. But what it really does is it'll get backlight. You'll see it in a minute, or you won't. Once it's through the RTC, it goes through the RTC reset. It just shuts off right away, and something's wrong with the I/O connector. It's screwing with the SMC, and it needs to go. And not so much. What's going on, Fuse Tech? You're slow right now? A lot of shops say they're slow, but I mean, it's been crazy here. I don't know what the deal is. Get a little holder for the screws. To make this easier, I'm gonna take off the eyesight connector. We'll solder a new one on. Yeah, I get my slow patches too, so don't feel bad. Trust me, this will not last. I'll get slow again. It's just part of the business. You know, it comes in waves. It'll be swamped, nothing. Swamped, nothing. That's how it is. 7 Oaks, how are we doing? Good. How about yourself? Webpage team fell through. Do your website yourself. Use Wix. That's what I honestly used. I know it's kind of embarrassing, but I use Wix. And Wix does a perfect job. It has e-commerce for free, and it does just a good job. So, and you know, I pay I have another website with my domain through Site Builder. I pay $10 for that a month. Let's see. Have a look at this eyesight connector. Not this eyesight, the I/O connector. I tried to touch it up, but it's still not working right. And it just needs to go. I can't see. Yeah, it's a little bit. It's not. But for some reason, it's not working right, so it's gotta go. You know, I'm not gonna just leave it there. Because it doesn't work right. I'll check it out. Okay. Let's get our stuff on. Plug in the fume extractor. And we will get to work. This looks like it's going to be fun to solder. I can see good, okay. I need to adjust this, I'm sorry. because I don't want to breathe those fumes. I replaced one of those connectors on time ago. Somebody jammed the connector. Yeah, that happens. I would prefer not changing it, but so I tried to touch it up. The eyesight connector's got to go too, because I'm not going to be able to fit my iron in there. Not the fan connector. Okay, that's still okay. I need to use a different hot air tip. The small one is not gonna do it. Hopefully that fan connector is still okay. Before we go further, let's see if our fan still spins. I don't want to have to change the fan connector too. It should still spin. Yeah, fan still spins. Okay, so you know what? How am I going to do this? Captain tape. Captain tape, it's not going to do much, but it's going to be better than nothing. So I know Jessa and them say it doesn't do anything, but it's going to be my only option. So now I'll find a pair of scissors that I should have in here, and they're not here. Here they are. This isn't going to do much, but it's going to be better than nothing, because I don't want to replace the fan connector or a DC and power connector. Okay, now we're going to switch our nozzle because this small one's not going to cut it. Hopefully we don't melt anything else. I want to use a lower airflow too. I have to apply to something. trying to use 30 liters a minute. I think it would be better. I don't want to melt anything. You take this big one off first. Just want to blow the air. I don't want to direct the air onto the fan connector. You know what I can use? I'm going to use some low melt. It'll make my life a lot easier. Any 8-2, I've come across dead GPUs. If that's what you're asking. But I don't do any BGA rework, so. I made a mess here. Oh well. No, I have not come across any new ones. I haven't come across, I don't do them, so I don't look. Okay, I made a mess. But now I'm hoping this is just going to come off, please. There we go. I did, but Linux are good. You can't really find good new ones though, from what I've heard. They're all just, you know, garbage. So we look good. Do a general cleaning of the area. Clean up all that old leaded solder. We're going to wick. The 800's a little too hot for this. Yeah, I'll, if I see one, like I said, I don't fix them, but I would just go on Amazon or eBay, not Amazon, the other one, eBay, and see if you could get any, but from what I've heard from Lewis too, I've wanted to get some boards fixed by Lewis, for GPUs, and he just said they die before they leave because you can't get good chips. So, you know, if Lewis can't get them, I don't think any of us are going to be able to get them. One second, guys. I gotta take a picture of something. Okay, we're back. Beep. Come on, there you go. No, I have not got a chance to look at that yet. Q-tip, clean up the area, and then we can get our new connector, and I won't use too much alcohol. But who cares? It's just 99, it'll dry. Our pads look good. Got our new connector. Okay, this looks like it will be really, really fun to solder. What kind of microscope do I use? I use an AmScope SE400Z or SE402 something, I don't know. It's all the same. SE400, SE402, SE420. They're pretty much all the same scopes. Sorry guys that you guys can't see right now, but I need to be able to see where I'm soldering this connector and I can't right now. is worse than one of the old LVDS connectors. This is not fun. Now it's not going anywhere. No, it's a 9-inch working distance on this scope. Where are my other tweezers? It's a question of my life. Where are my tweezers? Go a little hotter. Again. Is this a good one? SM6. What? Let me see. Let me Google that for you. Yeah, that's a good one. Yeah, if you can get a more expensive one, by all means. Okay, this sucks. This, I don't want to solder these connectors. Am I even soldering any of the pins down? Yeah, it just looks lousy, but looks don't matter. Of course it's off a little bit, but I don't care. Can't see nothing. This is when a micro pencil will come in handy, because this sucks without one. I'm going to push down on the connector and just drag. Like the LVDS connectors, just drag solder. Clean up some of this flux because I can't see. Stupid grommet screw is right in the way. Make any difference? Kind of. Now let's have a look and see if that's actually soldered. Oh, that's a mess. That's a big mess. Okay, let's get our solder wick. Yeah, this will probably end in failure. What happened was it bridged like everywhere on the side of this connector, so I'm going to put some flux down. I'm going to wick. Hi from the ashes. You've come to watch a failure. You've come to watch the attempt at soldering a connector. His went very badly. Brendan, we have a mess of me attempting to solder. Okay. Can I just drag my iron and correct this? I wish you guys could see. I'll show you guys in a second once I fix it, attempt to fix this. Yeah, you know what? I don't want to do this right now. Where's my leads? If these pins are all shorted to ground, yeah, you know what? On to the next one for now. I don't want to do this right now. So, this one, I don't want to work on. I don't want to change that connector because it's ended badly. So let's move on to the next one, which is an 820-00165 that has nothing on the screen. It does not work. So let's see what we have here. Clean all my those leads are dangerous. Yeah, they are dangerous. All these solder balls, come on. Get out of here. Get out of here. So let's see if we can fix this. This is an 820-00165 that does not show an image on the screen, had liquid damage on previous repair attempt, backlight circuit, and LVDS connector. It does not, I don't think it chimes. Let's put it in enclosure. Let's find an enclosure here. And let's test it. So, this may work, I don't know. I honestly don't know. Wait, we already have a DC on board. Last I know this was not working, but I just tested. I didn't put it in the case, see if it chimed. It may work, it may not. If it works, great, because I already did a bunch of work to it. If not, this may be a dead CPU, it may be something wrong with BIOS. It may be a bunch of things. Where are my tweezers again? Constantly losing my. Someone needs to invent something that. I guess it's called organization. Here they are. Could be SMC. Could be. It's more node brain. I don't think this chimes. I'm pretty sure it doesn't show an image on the screen. There's no light in the USB mouse. gonna get an image? Are we gonna get something? I really wish if this, I would be happy if this got an image, or something at least, or chimed it if it did something. Of course, my speaker connector is under the motherboard. Come on. I don't want to pull the board out to get the stupid speaker connector. Yeah, I have to pull the board out. At least tilt the board now. I have to pull the board out. I've rarely seen SMC cause no image, but not saying it can't happen. It could happen. Anything can happen. There's even a possibility of me actually fixing something tonight. That's not very likely though. Plug it in. We're gonna get no green light in the charger because no, let me just put it in the I/O board, just double check, just so I get a green light. Your RTC reset. So we're through RTC reset. We have no image on the screen. Or is it just no backlight? No, we got a chime. No image on the screen, no chime, and we're probably going to get no light in a USB mouse. Let's double check that. Go over what can cause this. No light in the USB mouse. So we have brain dead board. CPU is not being told to do what to do. So let's start checking the usuals. Now, this has had liquid damage to the LVDS connector. CPU got warm, so we have V-core. What could it be? That's could be BIOS, could be a bunch of things. So let's have a look at our BIOS area. The BIOS looks absolutely beautiful. So let's just go over. BIOS area looks beautiful. SMC area. Looks good. This has been ultrasonic, so it's not really gonna matter. I'm just gonna look through in the microscope and see if I see anything. Backlight driver looks great. Our clock chip. There's our clock chip. It's right here. Looks beautiful. Of course it does. So common thing with no image is if the clock chip is working but the crystal is not connected to the clock chip. So we have Y1905 or whatever it is right there, this thing. We gotta check the traces from that to the clock chip. So they're gonna be fine, but let's just double check that. And then I'm gonna try a new BIOS chip. Now keep in mind, you cannot just switch the BIOS on this. It would be only switched for a test until the ME region is cleaned or swapped from this one. So here's our Y1905, and this is gonna go to pin 4. And we're just gonna check. The traces look absolutely beautiful though. Yeah. Right, yes, this is a similar issue to what your board had. This is no image, no chime, but the thing with this is if we measure our platform reset signal by the CPU, or from the CPU, we will get a good 3.41 volts. Or 3.3 volts, whatever it is. So let's see. And so let me measure. You guys aren't going to be able to see that, so you will have to trust me on the measurement. But that should be 3.2 volt, 3.3 volts. So the CPU is working. Now, no image. We could either check the 32 kilohertz out of the clock chip, or we can replace the clock chip. I'd rather replace the clock chip right now than replace the BIOS. So I'm going to try a new clock chip and a new crystal and go from there. So now the hunt is to find a suitable clock chip that hasn't been stolen. And on this board, it is stolen. This board is too old. This board might actually have it. This is a 4924. 4924. So I have the same clock chip. Let's open up a. Yep. Okay. So let's repeal the coil. I mean the crystal. And Ray, this exact same thing was done to your board too, with the crystal and the clock chip. So just so you know what was done with your board. Also, position it. Let me move this over here. It'll work better. Clock chip, you need to take note of the orientation. So pin 1, the dot is going to be this way. This is the same board that you have too, Ray, so this will be interesting to see if this is the CPU. I don't think the CPU is bad on this board, but we will see. That's a little too much solder. Not center pad. Could leave it and just squish it out the sides, but I'd rather not. I'm fine with doing that with the ISLs and stuff, but not the clock chip. It's decent. Let's get a new crystal. For the chip. Yeah, if I just hit my head on the microscope. If this this clock chip doesn't work, it's either BIOS, and I'm probably not going to change the BIOS tonight, but I'm really hoping this clock chip works. Could be, what's this? Are those no stuff? Or were those knocked off by somebody that was here before me? I see something interesting. So see these, you guys can't, these pads look like something was there before. I'll check. It's interesting. More flux. And now we're going to press the chip down. Okay, first step, do we get a light in the USB mouse? We have a spinning fan. Let's do it. Do its RTC reset. Still nothing. CPU is getting really hot though, but that's good. But it's not good that we don't have a light. Let's try one more time in the enclosure. Let's see if anything changes. And I guess we'll check PMPCH power OK if this still doesn't work. And if that's present, if power OK is present and this thing still doesn't work, this is going to suck. It'll probably be either BIOS or CPU again on another 820000165 Broadwell board. Why these Broadwell chips are dying, I have no idea. They should not be dying. They're not even that old. But they are. I'm really hoping this is not another dead Broadwell CPU. So far, nothing on the screen. Okay, our fan is spinning fast, so the SMC is initialized. Nothing. I hate those boards that need to go. That should not be like this. So let's check PMPCH power OK. If that's missing, I'll fix it. If that's there, it's time for me to call it a night. I've never seen a dead Broadwell on anything but a MacBook. Wonder if it could be the routing. I've seen, well, I haven't seen dead Broadwell, but I've seen graphics in Broadwell failing, and me feeling around with a short, my finger through ESD hit one of the lines of the CPU or the graphics, and then it worked fine after that. It had graphics issues, then me feeling on the board when it's wrong, I hit a point right near the CPU. It froze. The screen shut off and it froze. I take my finger off, it came back on. It froze, restarted it, the graphics issues went away. So, how do you explain that? ESD repair. That was on a Dell though. That was long. I still have that. Dell is still here, actually. So PM PCH power okay, that's gonna come from U1950. And where's U1950 is right there, and it looks perfect. Of course it looks perfect. Brendan, no, it's not called magic, it's called unauthorized, unprofessional repair. That fixes stuff that the authorized people could never even think of fixing. And of course we have 3.3 volts on PCH power okay. Okay, so that leaves us with only a couple options left. We could have an issue in the one of the EFI termination resistors. Do I really want to go through all those and check them? No. So I'm just going to look, and the JTAG looks fine. CPU area looks fine. Do we have vCore? I didn't even check for vCore, but I'm pretty sure vCore is going to be there, unless my CPU is shorted. And we're also going to look, we're going to measure diode mode to ground on vCore, and why is this not turning on at all now? There we go. 1.8 volts on vCore. That's not the issue. Okay, let's measure resistance to ground on vCore. If we have anything less than 15, we probably have an issue. That's usually where Broadwell... 12 ohms to ground. That's not good. So we have 12 ohms to ground on vCore. That's a little low for my taste. Let me see on another board that I know has a working CPU. This chimes. This has a working CPU. And what is vCore to ground? Is 95 point something ohms to ground. 64.95 ohms to ground. That CPU is another Broadwell CPU dead. Let's measure. Okay, so we have. I don't know if Ray is still in chat, but he has the other board that's a dead Broadwell. Let's measure on his board and see what vCore is to ground. Is 13 ohms to ground, so almost the exact same measurement to ground on his board that has a dead CPU. So these are dead CPUs. These are dead Broadwell CPUs for no reason. The other one had liquid to the backlight circuit, and the CPU is dead. This one, what in the world is causing these Brendan, this is, you said you've never seen dead Broadwell. Well, here's two dead Broadwells in a matter of days. That's ridiculous. What is causing these CPUs to die? So, okay. Since this board, no, I don't. I was gonna say I could take the CPU off of this board and see. No, it's not gonna tell us anything, except our resistance will go up. What is causing these CPUs to die? That's what I don't understand. Did they take spikes? Did they get liquid under them? Did they get... Is it from just running so hot? I don't get it because... So, let me pull up a picture of a FLIR image of a Broadwell CPU running, and they run at like 185, just sitting there, and the fans are barely spinning. So I'm going to switch to display capture over here. Here's a Broadwell CPU running. 185 degrees and the fans are barely running. I think this has something to do with it. I think the heat on these CPUs has something to do with it. This is Intel's first 14 nanometer process, and I really think that these chips cannot take the heat. Intel says 100 Celsius or 105 Celsius for T-junction max. I think that's too hot for these chips. I think these chips are dying prematurely because of that. And if we look at the new Intel chips, they're all their T-junctions are at 85 Celsius, 90 Celsius. So I really think that the Intel may have realized that 100 something Celsius is too hot for the 14 nanometer process. Now the 22 nanometer process, the 32 nanometer process, keep that thing at 100 Celsius all day and it's happy. But the newer chips, I don't think they could take the heat, and I think that's why they're dying. That's the only thing I could think of. I mean, the two boards that have almost the same measurements to ground on vCore, and then at the same issue. Of course, I'll make sure to put your SSD back in. Now, everything will be fully tested before it leaves here. Honestly, I'm not sure what's causing these issues. It could be heat, it could be liquid under, but then again, the other board doesn't have liquid under it. You know, I don't get what's causing these CPUs to die unless it's the, no, it can't be the regs because it has 1.8 volts. Thinking I could try a little power through the vCore line, but what's that going to tell us? If we inject a little voltage, it's going to get hot anyway. One other thing I could think of, it's something connected to the CPU that's shorted and is holding vCore down, but no, that doesn't make sense because everything else is fine. And these boards have never had liquid on the vCore circuit. What in the world caused them to die then? Is it the PCH? I don't think it's the PCH that's dying. I think it's there's see, I've never seen dead Haswells. I've seen dead Broadwells. I don't know if it's the PCH part of the CPU or the processor part, or it's both, or it's the substrate. You know, I don't like to do this, but is it the solder bumps? So we have a board with a dead CPU. It's getting a replacement. So that board will not be used. Let's do a little test and let's see if we can figure out the method of failure on these chips. Is it in the die itself? Is it the solder bumps? What is it? So let me get that board, and we're gonna heat it. Time for BJ rework station? No. I'm gonna heat that chip. Not much, and let's see if we can restore something. If we could restore something, we know it's the bumps, and if it's from the bumps, we know it's if it's the bumps, we know it could be a heat issue. Where's my, and you know, I don't see this with Retinas, I see this with MacBook Airs. Where's my screwdriver? my screwdriver. Constantly losing stuff. Probably on the floor. I don't get how I could have something in my hand and lose it just like that. It's constant. Yeah, exactly. We can't get chips. We can't just go to Intel and ask Intel, "Hey, I want to buy a chip." You can't do that. They won't give it to you. It's not worked that way. Where did I put my screwdriver? I just had that thing. Literally just had that screwdriver. Do I need to get my other one? Yeah, but here's the thing. Once you pull that chip, it's been exposed to, too hot, and it's probably going to die anyway. So use another screwdriver since I can't find my other one. Oh, here it is. Why not just replace the board if it has a dead CPU? I'm not putting new CPUs on boards. And one, you can't, the CPU is tied to the BIOS. You have to clean the ME region on the BIOS too. So, is it the solder bumps failing in them? I really doubt it. Because Intel stuff, if it does die, it's usually the core. Make sure I have the right board here. Take the SSD out, let me mark it. I don't know what's failing in these chips. If it's solder bumps, I could understand that. But if it's something else, I can't understand that. Because okay. So now, to anyone watching this video, okay, do not think because your board doesn't work, do not take a heat gun to it because it does not work. We're trying to figure out what in the world is killing these CPUs. Is it the bumps? Is it in the core? Is it heat? What is it? If it's heat, the bumps would make sense because the silicon isn't really going to be infected by that from what I know. So let's bring the chip up to temperature slowly. And let's see if it changes anything. I really don't think if it changes anything, but if we get our platform reset signal back, then we kind of know it's probably the solder bumps on these. Again, this is not a repair. This is trying to figure out what in the chip is dying. Is it the bumps? Is it the die? What is it? So this is not a repair. This is not me, giving up and heat gunning it. This is already a dead CPU. It's a dead board, and we're trying to figure out what is failing. So I'm going to start at 170. Slowly bring the chip up to temp. I'm going to start increasing it. 230. 350. 412. 340. We want to slowly cool down the chip. We don't want to cool it down fast, else we'll have the same issue. 280. 170. 100. Blow cool air on it for a minute. That's good enough. Let's have a look. Should not know. See, when you do that, when people just burn them, that'll popcorn the chip, but what I just did isn't going to do it. Not bad anyway. Now the thing is, will it change anything? What failed? Is it the bumps or the die? If the bumps are failed, then I don't think this is the bumps. I think this is something in the core. But if it truly is the bumps, this will make it work again. But I don't think this is the bumps. I think this is more than the bumps. So it's still fairly hot. I want to let it cool down slowly. We don't want to just jump to cooling it down. And then tomorrow I gotta clean that mess and this mess over here. So I can safely put my hand on it, but I want to let it cool down. Nah, you know what? Why not? Let's plug it in. So what failed in this chip? Don't need a heatsink because, again, dead CPU. See if it even still turns on after that. Yep. Okay, now you know what? The chip burns me, and if you remember the video from before, the chip did not burn me. Remember how I held my hand on that CPU for, you know, 5 minutes and it didn't burn me? Well, now it's burning me. Let's freeze it a little bit. So it's cold. Okay. I'm gonna plug it in. I'm gonna put my finger on that CPU. Fan is spinning. And it burned me. So you know what? The something is different. Let's measure. Let's put the heatsink on because we don't want to burn up the CPU. Since now it's burning me, there's a very good chance that this is going to work. And if it works, it's the solder bumps again. And the reason why they're failing is too much heat. They're failing from too much heat from poor cooling. Again, this is a 2015 machine. This should not die this quickly. If any of you guys seen that video before, I kept my hand on that chip for at least 30 seconds and it did not burn me. Now I can't even do 5 seconds and it burns me. So we're onto something. What time is it? 8:50. No, this is an $800 machine. It's an Air. Yeah, that is unacceptable. I have my Lenovo ThinkPad that was made in 2013 or 14 or whatever. It still works. I have my other old ThinkPad from 2012 that still works. So let's measure platform reset L. and see if we even got anywhere. For all I know, the chip is just popcorned, and that's why it's getting so hot. But measure platform reset L. If this is normal, if this is reading, no, it's still missing. Still missing. But that doesn't make sense how the CPU gets hot like that now. Let's try it again. So something changed when we when that chip was heated. Something changed in it. Let's measure what V core is to ground now. Let's see. So now it's actually less. Now it's 10 ohms to ground. So that's why it's getting hotter. So what in the world is it? The die or is it the core? So heating it actually made it less resistance to ground. So that would explain why it gets hot. But what is failing? What is it? The bumps under the chip? Is it the core? Is it the layers in the die? What is failing that's causing it to do this? I'm not sure. And I don't really think we're ever going to find out. The only way to find out is put this through an X-ray and truly look at the bumps in the chip, see how the bumps look, and then look at the die if we could see the die. I don't know if an X-ray can even do that. Look at the wafer, but yeah. So 2 dead Broadwell CPUs, and that just, for the age that these are, that's ridiculous. I don't know if it's Intel's part, I don't know if it's Apple's part, I don't know what the deal is, but that's 2 of the same board in 1 week with dead CPUs that have no liquid to the CPUs. They're just simultaneous failures. So, well, didn't fix anything, but at least we learned something. So, thank you all for watching, and I will see you next time.